Assignment 6-2. This is about Riemann sums and how to approximate a definite integral using rectangles. So use the graph of y equals f of x at the right. I see it. To approximate the definite integral 0 to 8 of f of x. And we're going to be using rectangles. And there's three ways you could do it. You could use right, left, mid. You could also use a greater rectangle, a less than rectangle. Okay. So let's start with the midpoint one and understand what it means on this graph. And note that we have a table of values, so we don't have to pretend like we know exactly what the numbers are here to the right. All right. So first of all, we're using from 0 to 8, how many rectangles we're using? We're using 4 of them. So step number 1 is to understand how wide each one is. What is our width? And it's going to be 8 take away 0 and divided by 4. That's a good start. 8 take away 0 divided by 4. And the width of each of our rectangles is going to be 2. It's 8 divided by 4. So when I look at the first rectangle from 0 to 2, that's how wide it is. What's the middle value? And then go up. So positive 1 is the midpoint value. And we're going to set this up. So the height of the first rectangle is 1. And then from 2 to 4, the middle is 3, which is 3. And then from 4 to 6, it's 5 in the middle there, and it goes up to 1. 6 to 8, it's 7, and it goes up to 3. So that's using rectangles, length times width. When they all have the same width, it makes it easy to set up. This is what it looks like. So the width of each one is 2, and these are the heights. So you can just add up the heights times the width, make it simple. So that is 8 times 2, and that's 16. B. Left-hand Riemann sum. So still, this time it's 8 equal subdivisions. So now to find the width, you go the upper limit, subtract the lower limit, divided by 8. So that's obviously going to be 8 divided by 8, so that's 1. Now the setup. So for left-hand Riemann sum, we're using the left of the rectangle. So the first rectangle goes 0 to 1, and we're using the left height. So I'm not going to belabor it, but for each rectangle, it's going to be the left one. So we're going to use the value at 0, then 2, then 3. I'm just going to go here. 0, 1, 2, 3, 2, 1, 3, 3, and we end there because it's left. So we end at 7. So it's 0 plus 1 plus 2 plus 3 plus 2 plus 1 plus 3 plus 3, and then solve it. So there it is. These are all the left heights as you go across. So that's 8, 9, 12, 15. All right, C. Oops, I didn't mean to hit calculator. It's going to pop up in a second probably. Part C, a right-hand sum this time. And again, 8 equal subdivisions. So we just did that. The width is 1. And now we're using the right values. So for the right values, we're going to start with 1 and add up to 3 using the right side of the rectangle. So it's going to be 1 plus 2 plus 3 plus 2 plus 1 plus 3 plus 3 plus 3. So similar, but it's going to be 18 when you add it up. So there's the setup. These are the right heights all the way across, and you get 18. Number 2. Use the data in the table below to approximate the area between the graphs of f of t and the t-axis from 1 to 13. Use a midpoint Riemann sum with 6 equal rectangles of equal width. Plot the data, sketch a graph, and draw the rectangles first. So this goes from 0 to 13. So I'm going to draw a graph. And then it goes up to 18 as the greatest value. So I'm going to count by 3s. And that's f of t and t. So I'll show you my work right now. and then I'll plot. So there's my axes. So one is the t-axis and the f at t-axis. So I counted to 13, and then it goes up to 18. I just counted by threes. Now I'm going to plot them. So the first one should be plotted at 0, 0, and then 1, 5, 2, 8, 3, 11, 4, 12, 5, 15, 6, 17, 7, 18, that's as high as it gets, 8, back to 15, 9 goes to 13, so 9 goes to 13, 12 goes to 10, where am I at? I think I just lost track. 6, 7, 8, 9, I'm at 10. 10 goes to 12, 6, 7, 8, 9, 10 goes to 12, 11 to 9, 12 to 6, and 13 to 4. So that's what I have. I'm going to draw rectangles. Now, the first one, it says to draw a so we're going to use a midpoint, 6 equal rectangles going across, and it's a midpoint in terms of that. And we're going to go from 1 to 13, just so you don't, we're not starting at 0. So we're going to go 1 to 13. So I'm going to take the bounds 13 to 1. In fact, I'm going to set up what it looks like. So we're integrating from 1 to 13, f at t dt. We're going to estimate using rectangles, which is called Riemann sums. And we're going to use left midpoint Riemann sum. And we're using 6 rectangles. So first, I'm going to subtract the bounds and divide by 6. So I'm going to go 13, subtract 1, divided by 6. So that's 12 divided by 6. So the width of each rectangle is 2. And then the midpoint from 1 to 13. So I'm just going to go off the table of values and then draw it on there too. But between 1 and 3, the midpoint would be 8. And then between 3 and 5, the midpoint would be 12. Between 5 and 7, the midpoint would be 17. Between 7 and 9, the midpoint would be 15. Between 9 and 11, the midpoint would be 12. And between 11 and 13, the midpoint would be 6. So this is the setup. So those are all the midpoint heights, the middle heights. So if I understand here, so between 1 and 3, take 2. That's the height between 1 and 3. The next one is 1 to 5 and 4. Take that up here, and there's your rectangle. Between 5 and 7, you're going to take 6. So the middle value gives you the height of the rectangle. Shade it in. The next one the mid height here, between here and here, the middle of the height there, and again the middle of the height here. So it's always the middle value that gives you the height for a mid-Riemann sum. So that's what it looks like. And so if you find the area of each rectangle and added it up, that's what this is. Because they're equal width of 2, I can just go and add the heights and multiply it times 2 is a quicker way to calculate the area of each rectangle and add it up. And if I did this, I'm just going to look on the answer key for you. The answer is, in fact, they didn't even reduce it. You don't need to reduce it down. That's a great answer. Done. There it is. All right, number 3. And it's important to know on an AP exam for a Riemann sum, you don't have to calculate it all at the end. As long as it's numerically equivalent, you let it go and go to the next question. All right, number 3. It says use the data in the right table, in the table at the right, to approximate the integration from 2 to 4 f at x using a midpoint with 2 equal sub-intervals. So first, I take the bounds and subtract them, and then divide by 2. So the width is 4 subtract 2 divided by 2. So the width of each one is 1. And then if I'm just using 2 intervals, the mid, so from 2 to 3, the middle height is 2. And then from 3 to 4, the middle height is 3. And that's it. There's your answer. Just using rectangle. Easy peasy, right? There it is. So you find the width, and then the middle height, and then you have your answer. Number 4. All right. For problems 4 to 9, use the indicated type of Riemann sum to approximate the value of each integral. Draw an accurate sketch without a calculator if possible, and show your rectangles for each problem. All right, so I'm going to integrate from 2 to 8, 1 over x dx. So from 2 to 8, I'm just going to do a sketch of it. And what are we using? 3 rectangles. So for the first one, I'm going to go 8 subtract 2, and then divided by 3. So that's 6 divided by 3, so the width of each one is 2. And then we're using a left Riemann sum, just to get a sense of it. So this is what it looks like if you sketch it. So 1 over x, kind of this goes on forever going this way. There's a asymptote at 0, but it has this curve to it as it approaches 0. So from 2 to 8, if we use a left one, then at 2 would be the rectangle, at 4 would be the rectangle, and at 6 would be the rectangle. So those would be the rectangles you'd use. You would actually plug in to find the heights. So the width is 2, and then the left height you'd plug in 2 first, so that's 1/2. Then plug in 4, that's 1/4. Then plug in 6, that's 1/6. Do not simplify it. And there's the estimate. Done. Number 5. In number 5, it is, the same graph, but 2 to 8, but this time it's right. What would that look like? So, same estimation, but this time it's the right. Same thing. So if I use the right between 2 and 8, it's 4. Then it's 6. Then it's 8. So the right would be using 4, 6, and 8 for the heights. So again, the width would be 2, and then it would be, oops, plug in 4, so it would be 1/4 plus 1/6 plus 1/8. Ignore that. And don't simplify it. Perfect. Number 6. The square root of x plus 1. From 0 to 16. So first of all, what would the graph look like? And so this graph has just been shifted 1 to the left. And you're going 0 to 16. And 4 rectangles. So 16 take away 0 divided by 4. So it's 4. So first of all, draw your graph. And it's midpoint. And we're going 0 to 16. So midpoint would be like at 2. Then at 5, 5. At 6. At 10. At 14. So those are the midpoints. So just remember the numbers that you used. So first of all, the width again is going to be the upper bound, subtract the lower bound, divided by, in this case, 4 for 4 rectangles. So we're going to start with 4. And then what's the mid value? So we plug in 2, and it's the square root of 3. Plug in 5, and it's the square root of 6. Plug in 5. I didn't mean that. So plug in 2, plug in 6, which is the square root of 7. Plug in 10, square root of 11. And then plug in 14, square root of 15. Done. Obviously, don't simplify it. It's done. Number 7. So I'm integrating from 0 to 4, 1/2 x squared minus 2x plus 4. I'm going to tell you a quick way to graph this. This one's called a lower and then an upper. So when you do a lower Riemann sum, you're taking whatever the lowest height is. When you do an upper one, you're doing whatever the highest height is. I'll show you. First of all, how would you graph this? How would I graph this? So I can see that it's factorable if you work with it. So if I take 1/2 x squared minus 2x plus 4, I want to find the x-intercepts, or the zeros, to help me graph it. So I'm going to make it equal to 0. I'm going to multiply everything times 2. Is that going to help me? Oh, that is not factorable. That is not helpful. So what's the other thing I can do is I can use the formula negative b over 2a. It looks like it's factorable, but it's not. So negative b over 2a would be negative 2, which would make it positive. And then a is 1/2. So 2 times 1/2 is 1. So it's just positive 2. And then plug positive 2 into here to find the y coordinate. So 2 squared is 4. 1/2 of 4 is 2. Negative 2 times 2 is minus 4. And then there's just a 4 at the end. So that equals 2. So it's at 2, 2. And it folds up. And the y-intercept's at 4. So that could be helpful too. So 2, 2. 8 is almost the same thing as 7. So it's the same graph. and we're going from 0 to 4. So I'm going to use a little symmetry. So that means that 4, the answer must be 4. There's my graph. So I was able to graph this. There it is. The first one is a lower limit, and it says each rectangle is 1, right? 4 equal subdivisions. So if I take the upper limit, subtract the lower limit, and then divide by 4, the width of each one is 1. So if I look at 0 to 1, is the first one upper or lower? Lower. So if I look from 0 to 1, which number gives me the lowest height? And then you draw it. That's a lower one. Look from 1 to 2, which number gives me the lowest height? Look from 2 to 3, which one gives me the lower height? See how it stays there? Because 2 gives me the lower height of any one in the interval. And then from 3 to 4, 3 gives you the lowest one. So those are your 4 rectangles. So what would that look like? Well, the width is 1, and then you're plugging in 0, which gives you 4. You're going to plug in positive 1. What is that? 4 take away 2 is 2. That's 2.5. Oh, second. My apologies. The lower one here is 1. So let's try that again. So the lower one is 1, so that's 1.5. Then the next one is 2. That's the vertex. So that's 2.5. Is that what I said? 2.5. That's what I meant. Then the next one is just 2. And it stays again, 2. And then the next one would be at 3. So if I plugged in 3, it's 4 take away 6, which is negative 2. And then 9 over 2 is 4.5. So it's 4.5. Take away 2. So it's what, 2.5 again? And you can use symmetry actually too, because 1 and 3 will give you the same height. And that's it. You did it. That one's called the lower. Now for the upper, we're going to draw the same thing, but then we take the highest height in that interval for it. So again, I'm integrating from 0 to 4, 1/2 x squared minus 2x plus 4 dx. So we have, these are the points that I have. Now that I know it, it's 2.5. Might as well use 2.5. So when it's the higher one, then we're going to use the highest height in the interval. From 0 to 1, what's the highest height? We're going to use that. From 1 to 2, the highest height would be at 1. From 2 to 3, the highest one would be at 3. And then from 3 to 4, the highest one would be at 4. So here's an example of where you're using the higher limit, the upper limit of the rectangle, and using that for Riemann sum. So you can have a left Riemann sum, a middle Riemann sum, a right Riemann sum, left Riemann sum, an upper Riemann sum, a lower Riemann sum. So those are the 5 basic ones you can have. So again, the width of each one is 1, and then the first height is 4, then 2.5, then 2.5, and then back to 4 again, and you got it. All right, number 9. So in number 9, we don't have to sketch this one. Thank goodness. So, but it's good to graph. It's good to sketch. It's good to draw a picture. Sometimes it's a little tedious. So from -3 to +5, the cube root of x, subtract a half, dx. And we're going to use 4 left rectangles whose width are determined by an interval. Now this is far more AP exam-like, where the rectangles aren't all the same width. So if we're going to do 4 of them, the first width goes from -3 to 0. So the first width is 3. So from -3 to 0, that's 3. And if I use a left-hand one, I plug in the left value. So if you plug in 3, it would be the cube root of -3, subtract a half. Do not simplify it. The next width would be 0 to 1. That's 1. Zero to 1 is 1. And then plug in the left one, which is 0. That's just negative a half. So you can see what I'm doing again. So I'm doing each rectangle separately. So length times width, each one separately. So the first one was 3 by this. The next one was 1 by negative a half. And just each one separately. So 1 to 2 is 1. And then the left height, you plug in +1. You don't have to simplify it, so just write it in. And then the last one is 2 to 5. That's 3. And then use 2. And that's what it looks like. So each rectangle was done separately because there wasn't an equal width. So what's the distance between the x values? Gives you the width. This gives you the height. Don't even bother to simplify it. It's done. Number 10. All right, calculator, I can do that. So use a calculator to evaluate these. Take out your calculator. So number 10, and then I'll show you how to put it in radian mode if it's not. So number 10, we're going to press menu, then we're going to press menu, then we're going to press calculus, then we're going to press integral. We're integrating from, what is it? I'm just looking here on my other computer. -4 to 5. And then what's the integrand? 3x cubed. Subtract 4. And that is to the exponent. Oh, I should have started with parentheses. Let's try it again. Because it's all being to the exponent 10, right? So it's 3x cubed. Subtract 4 to the exponent 10. And that's dx. All right, there it is. Control Enter. Took forever. Now, be careful here. So you need to write that in, because the number is so small, actually so big, you need to write it in scientific notation. So that means 7.88 So that means 7.888 times 10 to the 24. That's scientific notation. This calculator does it. So if you ever see that, then you know what that is. Number 11, it has to be in radians. So let me just show you that quick. So to know if this is in radians or not, you're going to press the document button. That's the one on the right, top right, document, then settings, then document settings. See the second one? You just go down to the second one, and then you could change it and then press enter. And they go, yep, apply this thing, and then it's done. So, and if it's radians, obviously, what will it be up here? It would be RAD if it's in radians. All right, so what am I integrating again for the next one? Or for number 11? Oh, it says find the second derivative of sine x at pi 6, pi over 6. All right, so how would I do that with my calculator? Press menu, press calculus. This time we're doing the derivative. So the variable is x. What value is pi over 6? Pi is on the bottom left. So there's pi. And then control divide gives you a fraction, or there, pi over 6. So there's the number. Now it's the second derivative. So go to the second derivative and then press enter. And press OK again. So that's what it looks like. And then inside the parentheses you would type in sine x. So press the trig button. Trig is right beside the number 7. Make sure you put the variable in there. So there's sine x. It's all set up for you. Control enter, super simple, and the answer is negative 0.5. Number 12. So for number 12, this is find the area between 2 sine x and the x-axis in that interval. So in other words, first of all, do the integral setup. So we're integrating from pi over 2 to pi. What am I integrating? 2 sine x dx. And then put that in your calculator. So there's the setup to find the area. And then this is what it's going to look like. So menu, calculus, integrate. So we're going to go from pi over 2 to pi. And then what's the integrand is 2 sine x dx. There's your setup. Control, enter, and you get the answer 2. Done. So, do you have the ability to use your calculator to do some calculus? Yay. All right, what number are we at now? All right, use the graph of y equals f of x at right to graph each of the functions from problems 13 to 16. So this is not even calculus, it's just practicing transformational stuff. So let's see if we can do that. So in number 13, it's y equals negative f of x plus 1. So I'm going to take each key point. So that's negative 2, 0. That's 0, 2. That's 2, 0. And 4, negative 2. So that's each of the key points. And I know the first two make a quarter of a circle. So take each key point that I see on the graph and transform it. So if it's a negative and adding and subtracting, this is all in front or after the function. This only affects the y coordinate. So the x coordinate stays the same. If something happens inside the parentheses, then x changes. The y coordinate, I'm going to go times negative 1 and then add 1. So 0 times negative 1 is 0 plus 1 is 1. 2 times negative 1 is negative 2 plus 1 is negative 1. 0 times negative 1 is 0 plus 1 is 1. A negative times a negative is positive 2 plus 1 And those are the ones we're going to graph. So -2 and 1, 0 and -1, 2 and 1, and 4 and 3. Now this is going to make a line. And this is going to be, now remember it's been reflected, the quarter of a circle. So it's now going to curve like this, because it's been reflected down. So it has that curve and then a line, and that's what it looks like. That's number 13. For number 14, it's the absolute value on the outside. Do that. So the first thing, so I'm going to write it down. So the absolute value of 5x, f at x plus 1. And again, write down the key points. So -2, 0, 0, 2, 2, 0, and 4, -2. And then note what happens on the outside affects the y coordinate and inside affects the x, and it's the opposite of what I see, or the inverse. So we're going to subtract 1. Subtract 1. That'd be -3, -1, 1, and 3. So subtract 1 to each x value. The absolute value bars changes all of these to positive numbers. So if there's 0 or positive, they just stay the same. So really the only one that changed was this negative value. So we'll start with -3, 0, -1 and 2, 1 and 0, and then 3 and 2. So once you notice that this kind of creates a V right here. So it was a line that went all the way down, but the part that was negative got reflected up. Here, this is your quarter of a circle here that kind of looks like that. The next one is y equals 2f at -x. Again, the same points, so I'll show you the setup. So really the key is to understand how to transform points. And do you see the transformation in front of you? So what's on the outside affects the y coordinate, inside affects the x. So we're dividing by -1, so it creates a reflection. So take each x coordinate and divide by -1. Take each y coordinate and multiply times 2. So you're going to have a reflection over the y-axis and a stretch. So 2, 0, 0, 4. That's going to be that curve. That quarter circle now is on this side. -2, 0. It's going to be a line. And then -4, -4. That's going to continue that line there. So there it goes, -4, -4. So you have your line and your quarter of a circle. All right, let's look at number 16. So in number 16, you have y equals f, and then you have parentheses, the absolute value of x divided by 2. So we're going to start it the same way. We have our key points from the graph we're going to write down, and then we're going to transform each point, and then we'll graph it from there. Here. So those are my key points again. So notice nothing is on the outside of the function. Nothing in front, nothing behind it. So the y coordinate is going to stay the same. For the x coordinate, you do the inverse of what you see. So we're going to multiply times 2, and then the absolute value bars just makes all the x values positive. So negative 2 divided by 2 is negative 1, and then the absolute value makes it positive 1, and the y stays the same. Again, for 0 divided by 2 and the absolute value of 0, it stays 0, and then 2 would stay the same. Here, 2 divided by 2 is 1, and the absolute value of 1 stays 1, and it stays 0. And then 4 divided by, why am I dividing? Again, multiply. So 2 times 2 is 4. This should be a 4. Negative 2 times 2, and absolute, this should be a 4. After saying that, it's the inverse of what you see on the inside. Times. So you multiply it times 2 and then the absolute value. So this would be 8 and the absolute value. And then the y coordinate stays the same. I know. Okay. And for the absolute value of the x, in terms of what's happening, you really only have to graph the right side, and then it gets reflected over. So this is what it would look like. So counting to 8, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 and negative 2. We have 4 and 0. We have 0 and 2. Now, the thing with absolute value, it's a little tricky. For the x value, when the bars are on the inside, notice this is all on the right side. If I plugged in negative or positive numbers, it would end up being the same picture, but on the left. So I'm just going to, it's a reflection. And there you go. This should have an arrow. This should have an arrow, right? And an arrow at one end. This here. This should have an arrow. I think there's an arrow at one end, right? I didn't do the arrows. Right? Yeah, there's an arrow. Okay, so I'm going to do a second video on 13 to 20, whatever, 27. So, Mr. G Math over and out. I'm proud of you for doing your work. There's part 1 done. Take a break, and then you can do part 2 when you have the energy to do it. Always ask me questions. Keep fighting to figure it out, and I believe in you. All right? Mr. G Math, till next time.